balancing of redox reactions by using oxidation number method. What are redox reactions? The reaction in which both oxidation and reduction takes place is called redox reaction. What is oxidation number? The formal charges carried by the neutral atom after losing some number of electrons or gaining some number of electrons is called oxidation number. Now, let us apply this oxidation number to a redox reaction to balance the given reaction. Let us take an example. Ferrous sulfate FeSO4 reacted with potassium permanganate KMnO4 with a sulfuric acid H2SO4 gives ferric sulfate Fe2SO4 thrice plus this potassium and manganese will form their sulfates K2SO4 potassium sulfate, MnSO4 manganese sulfate plus water is a byproduct H2O. So, this is the given equation. Actually, this reaction is redox reaction. The given redox reaction is balanced by applying oxidation number. That is our topic. So, let us find where is the reduction reaction taking place and where is the oxidation reaction taking place. Let us first find those two reactions. So, this is step 1. Ferrous sulfate in this reaction is converted into ferric sulfate. This is oxidation because in ferrous sulfate oxidation number of this Fe is +2, but in ferric sulfate oxidation number of Fe is +3. So, oxidation number is increased from +2 to +3. When oxidation number increased, that is oxidation. This is oxidation. Oxidation. Oxidation number increased. And in KMnO4, oxidation number of this Mn is +7. And in manganese sulfate, oxidation number is +2. Here, oxidation number is decreased from +7 to +2. When oxidation number decreased, that reaction is called reduction. So, this is reduction. Reduction. Why? Because oxidation number is decreased. So, in the first step, we are identifying which one is oxidation and which one is reduction. And in the second step, let us find the number of electrons transfer. Ferrous sulfate FeSO4 plus KMnO4 potassium permanganate plus sulfuric acid H2SO4 gives ferric sulfate Fe2SO4 thrice plus potassium sulfate K2SO4 plus manganese sulfate MnSO4 and water byproduct. In the second step, as I told you, let us find the number of electrons transfer. So, here Fe is in +2 oxidation state and in potassium permanganate manganese is in +7 oxidation state and in ferric sulfate Fe is in +3 oxidation state. Here in manganese sulfate Mn is in +2 oxidation state. Number of electron transfer, how to arrive at? Here Fe when transfer from +2 oxidation state to Fe with +3 oxidation state, one positive charge is increased, so that one electron is last, 1 electron loose. And what happens here in manganese? Manganese with the +7 oxidation state, here converted into manganese with +2 oxidation state. What happened? 5 plus units are decreased. When 5 plus units decreased, we know that 5 electrons enter here. 5 electrons enter here. Gain of 5 electrons. 5 electron entry. But this 1 electron lose, 5 electron entry is happened only for 1 mole of Fe converted from left side to right side. But to convert these two ion molecule, we have to multiply this 1 and 5 by that 2, so that we will get 2 electron here, and multiplying this 5 electron with 2, we will get 10 electron. So, the number of electron transfers are identified in the second step. And in the third step, let us write the same equation again. Ferrous sulfate, FeSO4 plus potassium permanganate, KMnO4 plus sulfuric acid, H2SO4 gives Fe2SO4 thrice, that is ferric sulfate, K2SO4, that is potassium sulfate, and manganese sulfate, MnSO4 plus water. In this third step, let us crisscross the number of electron transfer. That means this 10 is written in front of this ferrous sulfate, and this 2 to be written in front of this KMnO4. So, what happened? Here 10 FeSO4 and here 2 KMnO4. This is third step. Third step is simply crisscrossing the number of electrons. And in the fourth step, let us write the same equation again with this 10 and 2. So, 10 FeSO4 plus 2 KMnO4 plus sulfuric acid gives ferric sulfate Fe2SO4 thrice plus potassium sulfate plus manganese sulfate plus water. Now, in this fourth step, you see this 2 and 10. When you write 2 here in right side, we should have the same number of 2K and 2Mn. Is it there? 2K is there in potassium sulfate, but 2Mn is not there in manganese sulfate. So, we should first properly balance this number of manganese by means of writing here 2 in front of manganese sulfate. So, what happened now? This 10 Fe should be balanced properly here in front of this ferric sulfate by way of writing number 5 in front of this ferric sulfate, so that the number of Fe becomes 5 into 2, 10. 10 Fe is balanced. After balancing Fe and number of manganese on both sides, we should calculate total number of sulfate here. 5 into 3, 15 sulfate plus 1, 16 sulfate plus 2, 18 sulfates. But in left side, we have only 10 sulfates. And in sulfuric acid, we have 1 sulfate. How to balance the number of sulfates? Those 18 sulfates obtained in right side of the reaction is properly balanced, leaving this 10 sulfate, remaining 8 sulfate is balanced in this sulfuric acid. How to balance? Writing number 8 in front of this sulfuric acid, the number of sulfate becomes 8, so that 8 sulfate plus 10 sulfate, totally 18 sulfate. Right side, we have the same 18 sulfate. The number of sulfates are now balanced. So, finally, in the fifth step, let us write the same equation with the numbers whatever we have written already. 10 ferrous sulfate FeSO4 plus 2 KMnO4 plus 8 sulfuric acid gives 5 Fe2 SO4 thrice plus K2SO4 and this 2 MnSO4 and water. Now finally, in the final balance, see this sulfuric acid will have 8 into 2, 16 hydrogen. But in right hand side, we have only 2 hydrogen. Finally, we balance this number of hydrogen 8 into 2, 16, 8 into 2, 16, completely balanced. Now this completely balanced equation is called stoichiometric equation that you have learned already. So this stoichiometric equation is arrived at, that is by applying oxidation number, this redox reaction, that means reduction oxidation reaction is balanced. Understand?